Good afternoon, everyone. Welcome back. My name is Patrick Gargano. I'm a lead content advocate with Learning and Certifications, and it's my great privilege. I just want to introduce Goran. So,
Hello.
Most of the time, the folks that have been up on stage here this morning and for the rest of the week are folks within Cisco and Learning and Certifications in particular. But this year, we decided to extend the invitation to our learning partners to see if any of their SMEs would be interested in coming and talk about what they love the most. Goran is all about this kind of stuff over here, but more than just that. But anyway, so really, really happy to see him, to have him come over and do a talk for us on some data center stuff. Goran?
Thank you, Patrick.
Cheers.
Yeah, first, thanks for the invitation, and I'm glad to be here in front of you. So, my name is Goran Martic. I'm working for a company, NIL Data Communications. As Patrick said, we are a global Cisco learning partner. We are based in Ljubljana, Slovenia, small country in southeastern Europe, but with a long and great Cisco partnership. We've been doing this for more than 3 decades now. And probably, as you can see, we are part, since a couple of years back, we are part of Konsha, a Danish company, also big Cisco partner integrator. So I guess we are part of a bigger boat. We are here today to talk a bit about hybrid cloud, something that we truly believe. I know hybrid cloud is everywhere. It seems like everything we hear these days is about hybrid cloud, but we really do believe about it. Specifically, what we'll talk about is a couple of things. First, why should we care? Secondly, why do we actually believe that hyper-converged infrastructure is the right foundation for the hybrid cloud? Thirdly, how does actually Cisco and Nutanix combine together to create that synergy needed for the hybrid cloud? And what are actually the ingredients of the hybrid cloud as such? So, there are many hybrid cloud definitions as there are different customers' environments. So we can agree there is no single hybrid cloud definition as such, because it means different things to different people. There are a lot of different use cases. And again, each environment is unique. But if you want to kid around a little bit, normally these days, hybrid cloud is considered like universal medicine to whatever IT headache you might have. But hopefully we'll be able to show why it actually matters. In essence, what we want with the hybrid cloud is we want Google, but within our own data center, right? That is, we want Google's DNA, that is the DNA of any hyperscale cloud provider, and leverage that when building out our own private data center. And then later on, that we are able to connect it to the public clouds. Like, this is the overall idea. Specifically, what we want to borrow from the public clouds is the, of course, agility, scalability, and high availability. And if that's not enough, on top of everything, the solution has to be simple to operate, and it has to be robust. It has to just work, you know. So it's a tall order to achieve, but this is the goal. And if we take a step back and actually assess why do we want to do this, well, in short, we want to get IT up to the speed of the business. That is, we want to improve the time to value. And secondly, we want to enable application mobility across different domains. But we now have to be extremely cautious about the resources. That is, we need to enable application mobility, but in a cost-effective manner. And thirdly, we actually want to find the proper infrastructure environment for some specific application, because now we have even more freedom, even more choice, which is a good thing, of course, but we need to be, careful. But the road to hybrid cloud nirvana is not straightforward. There are lots of challenges. First, starting with the fact that within the two domains, we normally have different hypervisors, which means that the format for the virtual hard drives is different. So you have to convert between the two somehow, right? Somebody has to do the conversion of the virtual hard drives. Secondly, and more importantly even, we have completely disjoint networking across the two or multiple domains or islands, right? We have different mechanisms for traffic separation, different mechanisms to apply networking policy, and there is no unification between the two. This is the biggest hurdle to enabling application mobility, because networking is completely separate. And thirdly, of course, the management tools that we are using across different domains are completely separated normally. Of course, these days we see some multi-cloud capable tools, but normally when you're starting out from your data center, typical 3-tier data center, you have separate tools for managing different components within the DC, which are not connected to any fashion to the public clouds. So these are the challenges for day one, at least. For day two, we have even more challenges. Day two meaning once you get your multi-cloud environment up and running, you need to manage it. And like within our own data center, we are used to having virtual machines with over-provisioned resources. It was fine because we are owning the equipment, but within the public cloud, this is a no-go, right? Because we are being charged for everything within the public cloud. So we need to be extra careful. We need to right-size the application resources within that specific public cloud environment. This is something new for us. This is something that we did not care that much in the past. So stuff like transparency, meaning who is using which resources, stuff like auditing, the controlling, the right sizing of resources. These are all imperatives in this new multi-cloud environment. And above all, again, we need to have a unified view across the different domains. This is also one of the imperatives. Like we cannot be using different metrics and different tools on the on-prem and on the public cloud. So why do we believe that HCI, hyper-converged infrastructure, is the perfect foundation? Well, with HCI, your life is much simpler. Like instead of having the centralized storage controllers, centralized storage arrays, and the whole networking that goes along with it, this is out of the picture now. We build out the hyper-converged infrastructure cluster by connecting multiple different x86 servers with local hard drives in them. Then we connect them with some top-of-the-rack switches. Of course, in our case, it's going to be fabric interconnects, and the servers are going to be UCS servers, and we'll see why. But in the end, what you get basically a collapsed environment. So you have hardware consolidation, less infrastructure footprint, but you retain the same functionality. Like within the HCI cluster, you get the server virtualization, you get the storage functionalities, and part of the networking as well, meaning the virtual networking, which is sitting within the hypervisors. Of course, again, still we need physical top-of-the-rack switches to connect everything. So hardware consolidation and hopefully software simplification. So hopefully the software, which is the Nutanix side of things, will be sitting on top of it and running the show. So here the architecture is completely different under the hood, but from the operational perspective, from the perspective of administrator, there's no change, right? Still, we are being given a cluster-wide data store on top of which we provision our VMs. So from operational perspective, there is no change whatsoever. And there's no compromise from the storage side, meaning that all of the enterprise storage features that we are used to are built into the solution, built into the product. So, of course, in HCI, normally we are using replication, like we build out 2 or 3 replicas of each chunk, of each block of data, and we distribute them across the cluster for protection. But all of the data optimization techniques like compression, deduplication, they are built in, also inline, that is before they're being written to the extent store and as a post process. And on top of it, some advanced techniques like erasure coding, which is basically distributed RAID, is also built into the platform. And as I said, the entire cluster behaves as a system, which means that data balancing across the cluster is happening automatically, or automagically, if you will, which means that data is being moved left and right between different nodes within the cluster, and also up and down between different storage tiers. And this happens automatically based on the application behavior and based on the capabilities and the capacity of each node. This is where Nutanix is unique. So it's doing this auto-balancing automatically for you. And also, you can leverage this cluster to provide external storage services to external clients, not just for the VMs and containers running inside the cluster. So You can expose, if you want block services, you can expose via iSCSI, expose the LAN externally to some external clients, even external hypervisors, whatever. Or you can expose file services like SMB and NFS based, and object services even with S3 compatible interface by using the same shared cluster. One of the great strengths of this joint solution is that we can actually now finally build out heterogeneous clusters, meaning that you can mix and match different hardware nodes according to your needs, which means that basically HCI cluster does not have to be uniform anymore. So if you want a converged node with additional compute and storage capacity, go ahead and add a converged node. But you can also add a storage-only node or compute-only node if you are happy with your storage resources and you just want to spin up more VMs. So you have this freedom or flexibility, which is inherently built into the architecture of the product, which is of course, great thing. What does this mean? It means that there are no rip and replace cycles anymore. So I can evolve my cluster over time, which is a great thing. Think about Google and let's say it's Gmail service. So we had Gmail running for more than 2 decades now. And can you imagine how many times has Google replaced the entire underlying infrastructure? Probably, who knows, 10 times over without having a global application downtime. Like, this is the holy grail. This is the goal that we are all seeking for. Like, we want this kind of a resilience in this kind of evolvable infrastructure to avoid those expensive rip and replace cycles within our data center. And this is what enables us to do so. And again, cluster recognizes the capabilities of each node and auto balances. Also, one of the big strengths of this HCI solution is that famously, probably you all heard about it, we can scale out linearly, meaning that when you add a new node within the cluster, what happens? You get, of course, additional storage capacity and additional capacity for running additional VMs, but also you get an additional storage performance. So each node brings with it a chunk of new IOPSes to the table, to the cluster. Because basically what is happening, each node is not just storing the data, but also processing the data, reading and writing. So basically the storage controllers which were fixed within a single box, they are now distributed across the entire cluster. So that's why you can scale linearly. Of course, this is theoretical. In practice, you will hit a limit and the performance at some point, let's say a couple of hundred of nodes, will start to flat out. But for our use cases, in terms of size and scalability, we are not there yet. We have not hit the limit. So linear scale out, no need to do those expensive forklift upgrades anymore. You can incrementally expand the cluster node by node when you need it, according to the type of resources that you need at that particular time. And this is a bit more on a marketing side, but you're going to have to trust me on my word. Basically, the solution is extremely simple, but powerful to use. I know it sounds cheesy, but it is true. Like, you have to use it. I've been using it for a couple of years. You have to use it to believe it. It's similar like what Meraki did for networking management. So this is taking the same approach. But at the same time, it's resilient. It just works, you know. It's very stable. All right. If we go one level down and take a look at the hardware infrastructure, what's happening, like what is the hardware foundation? Of course, we are using our tried and tested Cisco U solution, which enables us the stateless computing. We had this on the market for more than 10 years now, so extremely robust, extremely stable, and still we are way ahead of the competition. So no other vendor has this kind of a decoupled management. Probably you all know the story. With the UCS, you have the concept of a service profile, which contains the identity and the configuration of the server, and it is fully decoupled from the hardware itself. And then you can replace the server, apply the same service profile, and it brings it back to life with all of the same consistency, which means that we do not break the application, let's say, model. That is, we do not break the identity and the configuration of the server. Even down to the level of the MAC addresses and the system IDs, everything stays the same. Of course, all of the additional benefits, like being able to scale from the management perspective, like you can provision dozens and hundreds of servers at the same time, and maintain the same consistency without introducing operator errors, because it's policy-based configuration management. The second big pillar of UCS, why UCS is important for HCI, is networking, because any HCI system is basically a distributed system, which means that components, servers, that is the software deployed on the servers, is talking to each other over the network. So high-performant and highly consistent networking is an imperative here for any HCI system. Even though Nutanix is using data locality, still the networking is extremely important. And with UCS, of course, we have this nice unified and built-in network, which is also virtualized, which means that from a single physical networking adapter, we can slice it up into multiple virtual adapters. Each virtual adapter has its own, of course, configuration in terms of LAN and SAN connectivity, but also its own QoS policy, which means that we can unify multiple different virtual cables across a single physical cable, and we maintain the connection end-to-end, from the fabric interconnects all the way down to the virtual networking adapters, without any compromises, meaning that you get the same control, the same performance benefits in terms of quality of service, while you have the consolidated unified environment, which is much simpler to maintain and simpler to purchase in the first place. And one additional piece of the infrastructure component is, of course, the hypervisor. Although Nutanix and Cisco as well, they have strong VMware partnership. Nutanix actually started by running on top of VMware's ESXi, but now we have AHV, which stands for Acropolis Hypervisor. Finally, we have the open source solution, because this is based on KVM under the hood. It's basically KVM on steroids, because what has been done, the KVM has been re-engineered. A couple of components have been changed. Of course, all of the enterprise fancy management features that you see here, this is the first thing. Secondly, the block layer has been rewritten. Of course, KVM is known for its strong networking performance, so no need to change anything there. And of course, everybody's using KVM, let's be honest. I mean, even the AWS, the entire Amazon Web Services is powered these days on KVM. So now we have it as well, and this is something that you get free of charge when you purchase Cisco and Nutanix. So this is not being licensed. You are being licensed for the hardware. Of course, you have to pay for the Nutanix licenses, but when you pay for the Nutanix license, you get the hypervisor for free. It's there. You can use it. You don't have to use it. So now if you go back one layer up from the software perspective, like how do we manage? We have seen the hardware infrastructure. We have seen the HCI. How do we actually manage the entire stack? Well, we manage it from the HCI perspective through something which is called Prism. So in Cisco, we have Intersight. Intersight is basically there to manage the UCS servers and UCS networking via the service profiles. This is something that we know and love and like, you know. Well, Nutanix has a kind of a similar approach. So their HCI side of things, their stack is being managed through Prism. This is a one-stop shop, management shop for the entire cluster, which means that, of course, you can deploy, expand, and manage the cluster easily through Prism. It's quite straightforward. Again, you have to try to believe it. There's no other way. I can tell you all day, but just have to try it. Including the proactive management, it's already there. It's built in. So the similar approach that we have with Intersight, like, you know, with the security updates and field service alerts. So the similar proactive approach is built into the Prism already. Lifecycle manager, this is something that Nutanix is known for. Of course, we take the similar approach from Cisco side, but Nutanix is known for its robustness of its lifecycle manager. This is something that made actually the HCI famous in the first place. It's not that fancy, but it just works. It's there, and it's quite simple to operate. And lastly, the planning phase. I'll have a dedicated slide for that. Planning is extremely made simple. So you basically eliminate the guesswork from the planning phase. Of course, by leveraging the machine learning, what else? All right, I'll just briefly go through some of the core capabilities of the entire Cisco plus Nutanix stack. So in terms of monitoring and observability, you have two approaches. Like from the HCI perspective, from the Prism, you can do basic monitoring of the entire stack, from the hardware, hypervisor, all the way, and including the application level, okay? If you're not happy with that, if you want more granularity, more features, more metrics, of course, we have our own solution. Cisco has the workload optimizer, so you can go towards that path. Or if you want even more, you can go with the FSO, with the app dynamics and the full stack observability. This is for monitoring. For the automation, from the Intersite perspective, we have the Intersite Cloud Orchestrator, codeless automation. Nutanix has a similar thing from the Prism. It's called Xplay. That is a feature from the Prism Central where you can basically do the same thing, but from Nutanix side, you can only automate within the HCI cluster. From the Intersite, you can automate across the entire data center because Intersite can talk with the external storage providers and everything else. So it's a bit broader approach coming from Cisco. In terms of cost management and resource control and optimization, again, two approaches. You can leverage built-in Prism Central capabilities, which I will showcase in a second. Or again, if you're not happy, if you want more, you can leverage the Cisco's workload optimizer. And lastly, proactive remediation. Again, within the Intersite, you have the connected tech experience. So all of the, let's say, common issues with the RMA and with the field security alerts are streamlined and automated, and the Prism Central has the same capability as well. But again, just from the HCI perspective. Just to showcase a couple of features that I just went through. This is basically, I don't know how much can you actually see, but you see this, let's say, quadrant here. This is automatical classification which happens within the Nutanix, within the Prism Central. So basically, you have 4 categories. It's leveraging machine learning. What else? To classify the behavior of your VMs. And your VMs can be classified in a couple of different categories, like is it a bully VM, is it an over-provisioned VM, is it an underutilized VM, is it a zombie VM, and stuff like this. And this is something that you get automatically. It takes some time for the metrics to fill in, but you get the classification immediately. And of course, you can work your way from here by easily, clicking and finding the culprits. The second feature, the just-in-time forecasting and planning. Again, this is from the Prism Central. So what this allows you to do is to automatically create the capacity runways, like based on your history of resource usage, you get the runway when you are going to run out of some specific resource. What you can do from there, you can actually do what-if planning. Let's say you have a project coming up in 6 months' time, 12 months' time. You need to provision a bunch of VMs. You can factor that in as well. And if you're not happy with the end goal, you can expand. Logically expand. That is, do a what-if analysis, like what would happen if I would add more hardware resources into the picture. So all of that within a single screen. Quite powerful, simple but powerful. And again, you can do similar thing, but even more powerful across different domains with the Cisco Workload Optimizer. All right, and how does this relate to hybrid cloud, multi-cloud story? Well, here's the catch. We've been basically, up until this point, we've been building based on Cisco hardware, our own private cloud, right? With the help of the Nutanix stack. But what you can do with a feature called, or probably deployment option is a better term here, called Nutanix clusters, you can take this stack and actually extend it to the public cloud providers. So the Azure and AWS are in production now. GCP is still work in progress, which means that you can basically run and rent your own Nutanix clusters within the public cloud as well, and have the same unified view across the environments. Going back to my initial challenges, I said two things. First, I said that we have disjoint networking domains. Nutanix is automatically converting the networking mechanisms and policies for you. So here you have VLANs, here you have VPCs and VNets, depending on the provider. Nutanix will automatically translate between the two for you. Let's say here you have the AHV, and here you might have ESXi. If you have a replication setup, Nutanix will automatically do the conversion of the hard drives, of the virtual hard drives formats for you. So those challenges are being addressed from day one. And lastly, to wrap up, why do Cisco and Nutanix actually, hopefully by now it's a bit more clear, but why do Cisco and Nutanix make the perfect synergy for the HCI and for the hybrid cloud? Well, of course, what Cisco is bringing to the table, we said that we need to have like evolvable infrastructure, meaning we want to be able to rip and replace the hardware, and we do not want to care about networking. That's what we said at the start. These are the common challenges of the hybrid cloud. And this is perfectly aligned with the Cisco UCS benefits, right? So all of the stateless computing, all of the policy-based provisioning directly addresses these challenges. And of course, we have the Intersight, a single management plane to manage the hardware infrastructure. What Nutanix brings on the table, it brings state-of-the-art HCI architecture, because not every HCI is born different, right? Nutanix was the pioneer, and they are still the leaders in terms of the architecture, and architecture matters. So what do we have to do to actually combine these two together? That is what we will get when we combine them. Well, hopefully we will get the full simplicity, the freedom of choice in terms of flexibility, being able to choose different hardware, being able to replace the hardware, to evolve the cluster without those rip and replace cycles and forklift upgrades, and the solution should just work. And it is actually doing just that. Even today, like, this is not a promise for the future. This is like currently today. What do we have to do to actually make this, let's say, even a better seamless experience? Well, Cisco and Nutanix, they're doing the integration. That's what needs to happen. Because I've been talking from both sides, a little bit from Cisco, a little bit from Nutanix. And from Cisco side, we have the Intersight, which is managing the hardware infrastructure, including the networking, right? Because the service profiles are defined these days here. And from Nutanix, we have the Prism Central, which is basically multi-cluster management platform from the Nutanix. And what we are doing, like right now, we are doing the integration between the two. This is what Cisco and Nutanix is working on. And of course, this is a work in progress. As we will see during this calendar year, on the roadmap, we've seen some cool features. More and more integration points and use cases will pop up. In the end, going back to my initial slide, to the promise of hybrid cloud, what we will get full application mobility across the different domains without any issues in terms of networking and in terms of different management domains and perspectives. So hopefully by this, I have convinced you enough, and I've closed the show with what I have started with, addressed all of the challenges that we presented. Any questions, please? Please.
You mentioned that, I know this is a Cisco event, so I can't say anything else, but how about if you use different tools like Dell? I know they have the same.
Yeah. I don't know that any other hardware than Cisco exists, but let's say that the other hardware does exist. Well, what I said about the second part about Nutanix clusters, it is still true, but without what other vendors are not bringing to the table, they do not have the UCS and they don't have the intersite, which means that, including the networking, which means that the policy-based management of the entire service and the networking from a single pane of glass, this is something that you would lose. So it would not be as easy to replace the hardware. So thanks, a good one actually. Thank you. Yep.
With mixing the hardware, different hardware specs, is this a permanent setup or a migration state? Because they have different hardware, they have different CPUs, different memories, different storage.
Meaning, like, can you do it when you build the cluster?
Is it okay to put in different hardware specs as a permanent setup, or is it just a migration?
Okay, so the question is in terms of hardware heterogeneity when you're building the cluster, like, are there any limits?
Yeah, because you said it is hardware agnostic. You can put different hardware specs in the same